Hey guys, so in this video I'll just clarify one thing that one concept that confuses students about vectors. So let's say you have a vector. Let's take a simple vector first. Let's say that we have a vector A that is just 2 units in the x direction. So A is just 2I hat. Okay. Now this is your A. So the way you get the components of the vector, one way is you just subtract the coordinates of the tip from the coordinates of the tail. So you subtract the coordinates of the head from the coordinates of the tail. So in this case, the coordinates is 2, 0, and then 0, 0. So you would just do like 2 minus 0 I hat plus 0 minus 0, which is again obviously 0, so you just get 2 I hat. Okay, that's what I wrote over here. Now if I shift, so this vector is going to be 2 I hat no matter where I move it in the on the coordinate system. If I take it here, no matter what. Okay, even if I take it to the negative side, it's still going to be plus 2 I hat. So let's say I move it from here to here. Okay, so this is going to be like negative 1, 0, okay, and its head is now 1, 0. Okay, so that's now, so these are the coordinates of the head and the tail. So this is head and this is tail. So so you would get like A again as 1 minus minus 1. So 1 minus minus 1, and then it's again 0 minus 0. So that's I hat, and then 0 minus 0 j hat. So that again gives you 2 I hat. Okay, so this is true for any vector, even if you have a vector that has an orientation. It's like this. Okay, so let's say the coordinate of the head are 2, 2 in this case. So 1, 2, and then 1, 2. Okay, now even if you move this vector to this position, let's say you move it so that its head is on like its head is over here. So let's say you move it so that it's over here now. Okay, now the coordinate of its head are so 1 and then 2, and then this is negative 1 and 0. So again, if you want to write this as, so in the first case it's 2 minus 0, 2 minus 0. So the vector B, let's say, is so another way to write the vectors, if you don't want to write the unit vectors, is to just write the components. Let's use the concise one now. 2 minus 0 and 2 minus 0. Okay, that sort of gets rid of the clutter of I hat and j hats. So it's a nice way to write the vectors. So 2, 2, that's your vector. And if you move it, you have again, for the second orientation, you have B 1 minus minus 1, and then 2 minus 0. So that's the same as 2, 2, which is just 2 I hat plus 2 j hat. So that's again, this is something like this just signifies that your vector is independent of your coordinate system. So you're essentially shifting your coordinate system, towards the right over here, right? So no matter where you take your coordinate system, your vector stays the same. And this is particularly useful when you do examples in physics where you have like displacement vector, and you have to figure. Let's say there's a particle that moves from this point to this point and then back. So you always subtract so displacement, for example, in physics is delta x equals x final minus x initial. Okay, so that's an example where you would that demonstrates that no matter where the particle moves. So let's say that you have a particle that moves from like x equals 0, and then 1, 2, right? And then -1, -2. Okay. So if the particle moves from let's say A to B, okay, then the displacement delta x is going to be 2 meters. So these are in meters. Okay. Now, now if you shift your coordinate system, so this was the displacement of the particle, right? Now, even if you shift your coordinate system, so the plus sign is important here. For the displacement, it says that this is a particle that moves 2 meters in the positive x-axis, towards the positive x-axis. Now, this is going to be a particle that moves towards the positive x-axis no matter what, no matter if you choose your coordinate system such that it starts at -2 and ends up at 0. So for this one, you have like, this will be like 0 minus 2 meters, right? So you get 2 meters, still 2 meters, right? So the sign is important, and you have to make sure that you understand this concept that no matter where your coordinate system is, as long as the particle, the overall motion is towards the right, then your displacement is positive. And if your overall motion is towards the left, so let's say if it moves towards this direction, it will give you a negative displacement. So this is -2 meters. So no matter where you shift your vector, it's still going to be a negative displacement. Okay. So this was again a clarification. Thank you for watching. If you like the video, please subscribe. Thank you.